This is a video lesson for graphing rational functions, day 3. We spent the first 2 days doing simple ones. Now we're going to do medium level problems. These are going to get a lot harder, but we'll start with a medium level one here for today. And unlike yesterday, where, quick review, what we've been talking about is having just a number in the numerator, x minus 8, so only a number here, no number in front of x, and then a k value. And the asymptotes were pretty simple. We can get our asymptotes simply from these two numbers. That's what we did yesterday. Well, now today, what we have is one fraction, but it gets a little more complex. There's more going on in the numerator, and there's a number in front of x here. This is getting closer to being able to graph general rational functions, really any type of rational function. So we're going to analyze three things. We're going to do both asymptotes again, and we're also going to do an x-intercept. We're going to expand this to be a lot more general. I'm going to give you some formulas, but I'm really hoping that you can learn how we come up with these asymptotes and the x-intercept, and understanding how they're done instead of just memorizing the formula would be ideal. So first of all, vertical asymptote. The vertical asymptote exists when the denominator equals 0. We've talked about this a little bit already. Where is there a break? Where is there a part of the graph that doesn't exist? It doesn't exist when 0 is in the denominator, because you cannot divide by 0. So whatever x value would make this denominator come out as 0, that's where your vertical asymptote is. Now in this particular format, if the denominator is bx plus d equals 0, and we solve for x, we would get x equals negative d divided by b. So the vertical asymptote as a formula is always going to be x equals negative d divided by b. But really all we're doing is setting the denominator equal to 0 and solving for x. Horizontal asymptote. This gets pretty complex, but for now we're going to keep it pretty simple. It's the leading coefficients a and b. A leading coefficient is the first coefficient when they're polynomials are written in order. So the leading coefficients are a and b. So the horizontal asymptote for now should be simple. It's y equals a over b. And then the x-intercept. This exists when y equals 0. But because of the way this format is set up, the denominator really doesn't play a role. It just comes down to the numerator. So if we set the numerator equal to 0, similar to what we did up here for denominator, set the numerator equal to 0, ax plus c, I would get negative c divided by a. That gives me my x-intercept. So that's a quick rundown. I do have a diagram here, a little graphic that might be helpful. Here's our fraction, here's the numerator, here's the denominator. And I have the circles lined up telling you each one. Vertical asymptote, you set the denominator equal to 0. X-intercept, you set the numerator equal to 0. Horizontal asymptote, it uses the leading coefficients. So maybe that graphic would help. And again, this document will be posted. All right, let's do a couple quick examples, starting with 3x plus 6 divided by x minus 4. So we're going to start with the vertical asymptote. The vertical asymptote, I take the denominator, I set the denominator equal to 0, and I solve. I would solve for x by adding 4 to both sides. X equals 4 is where the vertical asymptote exists. And we'll jump down and you can see here, here's the graph. X equals 4 is my vertical asymptote in green. And then the horizontal, y equals 3 over 1, because I use the leading coefficients, 3 over the unseen 1. So y equals 3 is my horizontal. And you can see that here on the red line. X-intercept. This is where I set the numerator equal to 0. If I set this equal to 0, I would minus 6 divide by 3. Negative 6 over 3, or negative 2, is the x-intercept. So at negative 2 comma 0 is the x-intercept. I did pick 2 more points just to help me sketch this function. May only need 1 more, maybe 2. I got 1 and 7 gave me some nice clean points, and then I can see it following the asymptotes. Now, on this graph, we don't see it getting real close to the asymptote yet, because this is pretty stretched out. But as it goes this way, it will continue to get closer to this asymptote, closer to this asymptote. This swoops up and becomes closer to this asymptote. Likewise, this asymptote. And we'll keep following those. Let's go down. Take a look at the next one. I have negative x minus 3 in the numerator, 2x plus 7 in the denominator. Okay, so again, vertical asymptote, set the denominator equal to 0. Whatever makes the denominator 0 is where the graph doesn't exist. And since it doesn't exist, that's the vertical asymptote. So 2x plus 7, I say that and set it equal to 0, giving negative 7 over 2, or negative 3.5. There's my vertical asymptote. Negative 3.5. Horizontal, leading coefficients, negative 1 over 2, negative 1/2. That's my horizontal at negative 1/2. And there's my red line at negative 1/2 as a horizontal line. X-intercept, let's take that numerator, set it equal to 0. I would add 3, divide by negative 1, so negative 3 is the x-intercept, and there it is. That's a pretty good point. This isn't far away from the asymptotes like the last one that we're swooping farther away. This is nice and tight. 1 point's enough. I'll get 1 point over here. Let's just do negative 4. You can see there's some symmetry happening there. It's kind of equidistant from where the asymptotes intersect. And it swoops and follows the asymptotes in both sections in both directions. Make sure you get on and complete the practice problems.